almost no one knows the name also. Get KP, Zero Knowledge Proofs. And some queries already came. What is this topic? Nobody heard this topic. So I think definitely it is interesting. And I welcome once again all the participants for this 142 webinar. I thank you so much, Sir Rajesh Kulkarni, sir, for coming forward and delivering this webinar within a very short notice and also a new trending topic. As you're all aware, our IETE Hyderabad center is the second largest center in India out of 65 centers. And ours is very active center, and continuously we are conducting the various workshops, seminars, conferences, and also memorial endowment lectures. And apart from this, regular webinars from July 2020 onwards. So in this reach, we are reached about today 1/10 knowledge sharing session. I thank once again all the webinar speakers for coming forward and deliver their talks, and also along with all the participants, student members, corporate members for continuous cooperation for conducting these webinars. Now I request our EC member and chairman Technical Programs Committee, Dr. Ravi Krishna Prasad, to read the brief biodata of Dr. Rajesh Kulkarni, sir.
Okay, sir. It's my pleasure to introduce today's speaker, Dr. Rajesh Kulkarni is also my colleague. We both are working in MVSR Engineering College. Dr. Rajesh Kulkarni is professor at MVSR Engineering College. He is an advisor to Pune-based startup SpeedTech Server. He mentored and now is a distant associate for IP Adventure, LLP company and IPR startup. He is founder of Uma Publication, Nanded and Cave Academy, Pune. He served also constant mentor at Ignition Incubation Center, Navi, Mumbai. He is a passionate teacher, motivating speaker, author, publisher, entrepreneur, and a change agent for organizational transformation. He published several books, many research papers in SCI, Scopus journals, 12 patents, copyrights, and several trademarks, and 2 design patents also. Dr. Kulkarni graduated from BAMO, Aurangabad in Computer Science and Engineering. He did his Masters in Computer Science from JNTU Anantapur. He completed his PhD from JNTUH Hyderabad. His major contributions in previous organizations, Mission 300 Training Initiative, MOUs with industries, stakeholder reach out through constituting awards, Alumni Excellence, Vidya Vibhushan, Sikshak, Gaurav, 101 top professional educators, career awareness seminars across 11 cities, 64 locations, addressed more than 2 lakh students, MOUs with the foreign universities and foreign industries also. I welcome you, Rajesh Kulkarni, sir. Please share your knowledge.
Thank you for such a wonderful introduction, my friend Krishna Prasad, sir. And thank you, Om Namah Shivaya, sir. Again, my dear friend, for giving me this opportunity. And thank you, IET, for having me. And hopefully this session will be at least sensitizing all of us regarding this topic. So let me share my screen and start my topic. Just confirm whether I am audible or not. Am I audible?
Audible, sir. Yes,
okay,
sir.
Thank you.
Audible, sir. Any screen sharing?
Yeah, I am sharing, sir. I am sharing.
Yeah.
Okay. So just before starting again, if there is by mistake something happens, the power goes off, something like that, give us 2-3 minutes to come back again. If there is a internet connectivity issue or something like that. Okay.
Okay, sir.
So put it in a slideshow, sir.
Yeah.
Yeah, nice. Nice.
Thank you. Thank you. Yeah. Zero knowledge proof. This is my topic. and this is me, Rajesh Kulkarni from MVSR College. And the moment Om Namah Shivaya sir started propagating this flyer of this topic, like most of my friends who are in IT industry also expressed that they had zero knowledge about this topic. So that was an interesting comment received. But this is a very, very old topic, we can say, uh, started in 1980s. But why it is in prevalence, why we are discussing it today, because now it is the most futuristic, important cryptographic tool which will be looked after, sought after, learned after by many of us from the IT world. Uh, because now it is a cryptographic tool, first point. Second is it is now connected to decentralized ledgers or blockchains and so on and so forth. So let us try to, uh, through our broken thoughts, try to connect the dots and try to understand this topic called as zero knowledge tool. Okay. Hope my screen is visible to you. I request you all to just glance it, maybe read it one or two times. Just a request to read it one or two times on.
Sir,
It's
voice is
visible, sir.
Okay.
yes, sir.
Okay. Screen is visible, right?
Yes, sir.
Yeah.
Visible, voice is breaking.
Okay. 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 I'll just remove this.
Sir, not audible, sir.
Am I audible now?
Now it's clear, sir.
Okay. So I was requesting all the participants to just go through these keywords, read it once or twice. I'll give a pause of maybe some 1 minute. I'll also read it twice. Yeah. So I request a few of the participants to just respond regarding any of the keyword which is visible there on the screen. Uh, Maybe the keyword you may be liking it or the keyword you may be knowing it. Any of you, I request you to respond one or two keywords from the participants.
Dark web, sir.
Fantastic, fantastic. So, sir has raised one word called as dark web. So let us just try to connect with dark web. I know that when I speak about dark web, I'm speaking about something called as surface web. And surface web is the whole day internet browsing which I do. Every day I browse, I email, I use social media, I do online transactions, I Google search, I use various search engines. That's what is my surface web. But that surface web is around 4% of the actual internet uh, content, so to say. So the remaining 96% of the web, many of the advanced users usually go to dark web or deep web and use special search engines like Tor. Use special search engines like Tor. Tor again is a keyword here visible to you. It's a protocol actually, the onion router protocol, uh, which people will be using for accessing the web. Uh, I request people to just go on mute. Go on mute. Few of you are. Please go on mute. Okay. Thank you. Thank you. So I was speaking about dark web, and I was saying that dark web can be accessed with the help of advanced search engines like Tor. Okay, the Tor is the onion routing protocol, and what is the beauty of dark web? That if I am accessing dark web, people will not know that location of my machine, or people will not know that I am accessing, because it will be bouncing off to multiple places, and then whatever is to be accessed, there is access. So thank you, sir, for highlighting this term, dark web. Any other person, please raise any word which you like. I'll ask for only two more words. After that, we'll just go through each word. Request any one of the participants to raise any other word which you feel you like it, which you feel is interesting, which you feel is anything. Any one word among the participants?
Blockchain.
Fantastic, fantastic. So we know about blockchain, right? So blockchain is what? Blockchain is a distributed ledger. Blockchain is more of freedom. Blockchain is more of the cryptocurrencies which we speak about. We speak about bitcoins, we speak about nanos, we speak about iota, we speak about monero. So blockchain is the crux for all of them, and we know that the beauty of blockchain is it will be removing the how do we say, the middleman. The middleman is removed. Say for example, you and me are transacting, we are exchanging money. So the middleman here is a bank. So the banking entity may be removed. So that's what blockchain is. A transparent, blockchain is open source, blockchain is visible to everybody, so it is public basically. So blockchain has two words, you can see here, block and chain. So block is just a record, so chain is these records, multiple records are we can say chained together. So that's what is a blockchain. And I have a small PPT which will make a walkthrough of about blockchain. Let me just go to that PPT. That walkthrough will be very for a few minutes, maybe 3-4 minutes max. Give me a minute. Okay. People said this person was responsible for blockchain. But this person again is not a person, they say it's a group of anonymous entities. But what exactly is blockchain is this? It's a digital ledger, it is distributed, it is trust-based. Blockchain has list of blocks, it uses hashing algorithms like SHA or MD5. Okay, so till now it is unhackable, what they say. Okay, so if you look at this diagram, on the right side you see the distributed ledger, and this distributed ledger is the concept of blockchain. On the left side you see there is a centralized ledger. So here you can see a centralized ledger is bank.
Hello.
Yeah.
Hello. Slide side's not moving.
Okay. I'll try to do it again. Is it moving now? Hopefully the slides are moving now. Are they moving, sir?
No. Only first slide is there.
Yes. Yeah, it's moving.
It's moving.
Moving, sir.
Okay.
Slides are moving.
Okay. If the slides are not moving at your end, just listen to me also. I try to compensate through what I talk. I'm speaking about blockchain for a few minutes, and I was saying that blockchain is a digital ledger of transactions. Okay, it is distributed. It uses hashing algorithms like MD5. Okay, it is secure and trust based, and this is the diagram which tries to highlight blockchain as a distributed ledger versus the traditional centralized ledger. How to differentiate a blockchain is, you can take an example of bank. So suppose you are transacting money, transferring money to somebody, receiving money from somebody, anything you are doing related to money. In between there is an entity called as a bank, right? So that's the example of the centralized ledger. So what they say is blockchain is a distributed ledger, as in this middleman called as a bank is removed. So that's the concept of blockchain. As depicted here in this diagram, block is nothing but a bundle of records. And so all the blocks, if they're linked together, then it becomes a chain. That's why maybe the word blockchain has come. So you can see here, a blockchain is formed with multiple blocks. What exactly is a block? Maybe is it can be a transaction. Say, for example, Sam has sent an amount of 200 bitcoins to Peter, kind of thing. So as you can see here, every block has a hash, and every block has a previous hash. And hash, we'll be using hashing function to generate hashes, which can act as a unique fingerprints of the blocks. Okay, so again, this video, I'll just run it not entirely for 1 minute max, just to create an understanding, or I may fast forward it also.
This is a blockchain demo. We're going to do this in a very visual way, though. This is a fingerprint of whatever I type in this box. So
here you can see a block representation, and below you have a hash representation, and whatever data I generated, a unique hash for that is created. Let me go to a blockchain, and then and here again you can see here, now you have your data, you have your block number. If it is not visible, it's okay. But still, I'll try to show what I want to show, or tell what I want to tell. This is a representation of a block, and every block has the block number here as a representation, a nonce, the data, and the hash. So let us try to see the representation of a blockchain. If it is there somewhere, yeah. You can see here a blockchain. So every block has a previous hash as well as the current hash. This will be used for connecting these blocks. So now coming to a few of the applications, you can see here, blockchains can be used for e-voting, online transactions, or digital IDs like licenses, driving licenses, kind of things, banking, everywhere. I'm just showing which I want to show. These are few of the use cases which are already implemented in some countries. Say, for example, digital currency is used in few countries or many countries nowadays. This was implemented by Wipro, R3, because Wipro is strong in blockchain projects. That was in Thailand. So driving licenses, IDs, proof of age, all these kinds of things were used using blockchain. So in travel agencies also, loyalty programs, baggage tracking, secure payments, for all these cases also blockchains are used. I'm going intentionally a bit fast because this is not the crux of our topic, just to connect the dots with our topic JetKP. So even in sports, blockchain is used to eliminate middlemen, to regulate transparency, drug testing, and those kinds of things. So let us go back to our main slide again. So I'll now read out each of the word, and I try to highlight what exactly is that, and in some way they add to the topic which we are discussing today. Say, for example, GDPR. Okay, so this is given by European Union, very stringent, very strong, high penalties kind of regulation it is. This is for actually data privacy. This is general data privacy regulation. So as we know, say for example, nowadays we all have been sharing all the information everywhere, be it on social media, be it if I want to apply for something, I will have to give my identity, my age, my Aadhaar card, my PAN card, many of the things I may be sharing. And my data, my private data is being available to multiple entities, be it governments or be it private companies, be it social media entities like Facebook. There is a chance that it is happening that my data is being traded by these companies or even governments. So it is highly probable that what are my orientations, what I like in buying, what I don't like, all those aspects may be sold by Facebook to some company. That company will be using their advertisements as per my need, that kind of thing may happen. So the next word I'm referring is POW. So better what I try to do is, instead of I have a PDF, I just make a walkthrough of that PDF. So these are the 2-3 words which we have used. The next word which is visible is POW. So POW actually is a proof of work. So this proof of work is created by the miners. Now miners again is a keyword related to blockchain. Okay. So who are miners in the blockchain world? They are the ones who verify the blocks. Okay. They will be verifying these blocks with their CPU power, and for that they will be rewarded. So
సార్ సారీ టు ఇంటరప్ట్ యూ సార్ వాయిస్ బ్రేక్ అవుతుంది సార్
okay, I come nearer.
నో వాయిస్ సార్ నో it's now not audible, sir.
Better. Krishna Prasad sir, just confirm if it is audible.
Now it's clear, sir.
Okay, thank you. So I was speaking about the keywords which are shown on the slides. We spoke about GDPR, then the dark web, then blockchain. We are speaking about POW and miners now. So POW is nothing but proof of work. Okay. So this proof of work is given by the miners. Miners in blockchain world are the one who verify the blocks of the blockchain. For that verification, they will be using their computing power. And as they are using their computing power, if they get a 50% consensus for the block they verified, that block will be added. And for that, they will be awarded. Okay. So here, one more terminology called as norms also plays a role in this POW. So norm stands for, how do I put it? It's a number which will be used only once. Okay. So, and miners use this. So identifying the norms for verification. Okay. So as I told, miners will be verifying the blocks through the proof of works, and for that they will be rewarded with bitcoins. The next keyword is mempool. And mempool is memory pool. Okay. So this memory pool has nothing but list of pending transactions. Okay. So only if the transaction on a blockchain, if it is verified by the mempool, approved by the mempool, then only it can be added on the blockchain. There is one more word called as MEV. MEV stands for maximum extractable value. MEV stands for maximum extractable value. So how much a miner can extract, some limit in a given time frame. Now this is the famous tool, next tool called as Zcash. Okay. It is for cryptocurrency, it is for transactions. Okay. So it is based on Bitcoin's code base. As we all know, Bitcoin has a limitation of 25 million units. Same is the case with Zcash. Okay. Here, blockchain, what is blockchain? Blockchain is transparent, right? So similarly, Zcash can be transparent. Okay. But Zcash can also be shielded. Okay. Zcash can be shielded with the help of ZKP. Now, here the topic, what is our topic? Zero knowledge proof. And we have referred zero knowledge proof for the first time in our today's discussion. So where we use zero knowledge proof for the first time, now we are saying that we started with blockchain. Then we started with cryptocurrency. And with cryptocurrency, we said bitcoins are there, nanos are there, moneros are there, iotas are there. Many kind of variations are there. And there is again a famous tool called as Zcash. You can call it an app, which is basically for cryptocurrencies. Okay, so it will be helping in transactions and kind of thing. But Zcash has both the properties. It is transparent as blockchain. It can also be shielded. It can also be shielded means now the users may not want to share all their information. They want to hide something. So in such case, it can be shielded. For shielding, zero knowledge proof will be used. Okay, so it means where the role play of zero knowledge play has come for the first time in today's discussion, it may be used for some hiding. It may be used for some anonymity. It may be used for shielding. So in the world of blockchains, it means what? Zero knowledge proof, cryptography, cryptocurrencies, blockchain, all these are interconnected. Rather, if you want a trade-off, kind of transparency and confidentiality, so then zero knowledge proof comes into picture. So we spoke about Zcash, okay? So that's why it is a selective disclosure, hiding kind of thing, or anonymity kind of thing, okay? The next keyword we are referring is ZK-SNARK. Now, I'll repeat a word which I feel is more connected to today's topic, zero knowledge proof. The next word I'm going to say is ZK-SNARK. Let us try to understand the long form of ZK-SNARK. ZK comes from ZKP, and ZKP is zero knowledge proof. And zero knowledge proof is connected to blockchain, which is transferred to make it more shielded, more hidden kind of thing. Now, ZK-SNARK is what? Now we know what is ZK. ZK is zero knowledge. Let us look at the word S, letter S. S is a succinct. Succinct is small, I can say. Okay. N is non-interactive. Argument, A is argument. Okay. AR is argument, rather K is knowledge. Okay. So ZK-SNARK again is a proof. You can say it is ZKP only. Okay. Where somebody can prove that he has some secret key, but he need not tell anything about the secret key. So it is comes again. I am highlighting ZK-SNARK with ZKP. So ZKP is zero knowledge proof. Zero knowledge proof is it is more on the lines. I know the secret. I'll not tell the secret, but I'll prove that I know the secret, kind of thing. Okay. It is not just my statement. I know the secret. I will prove to you that I know the secret, and you will get convinced with my proof that kind of you are a judge, and you are getting convinced that I have the secret kind of thing. Okay. Zcash and ZK-SNARK we referred one after the another. Rather, Zcash is the application of ZK-SNARK. Okay. Okay. Next is Hamiltonian cycle, which we are using in our graphs. Wherein the path is created in such a way that each vertex of the graph is visited exactly once. Now, this is one of the, again, very famous term in our Bitcoin world, cryptocurrency world, Ethereum. Again, this is a decentralized blockchain. Smart contracts are possible. Its cryptocurrency is called as Ether. Next is Bitcoins. We all are aware of Bitcoins. Rather, everybody knows the word Bitcoin, but many of us, including me, don't know that it's a huge world of Bitcoin and Bitcoin's cousins, family, and so on and so forth. Who can be such cousins or warrior fighters or brothers? They can be nanos, they can be moneros, they can be iotas, they can be ethereums. And so it means in this market, there are many players. In this cryptocurrency market, there are many players. Okay. Let us look at the next word, which is related to our topic. What is our topic? ZKP. And with what is ZKP? ZKP is zero knowledge proof. And zero knowledge proof, two keywords which we said are related. One is Zcash. The other one is ZK-SNARK we have used. Okay. The other next term we are using is ZK-EVM. Okay.
So here ZK we already know. ZK stands for zero knowledge. Okay. And VM we know. VM is virtual machine. And this is a connect with Ethereum. Okay. So what we are doing is we are integrating ZKP. We are integrating ZKP to Ethereum. We are integrating ZKP to Ethereum. Okay. And what exactly happens here? What is Ethereum? Okay, it is a blockchain. What is Ethereum? It is a blockchain. It's a public blockchain. It's a transparent blockchain. Now, this Ethereum or any of the blockchains, the characteristics is they are very slow. The characteristics are as they are, how do I put it, decentralized, multiple nodes are connected. There is no central agency handling them. So what can happen is whatever the computations, complex activities to be done on those transparent blockchains, they can be, that workload can be taken off from them and that can be given to say ZK EVM. So you can say ZK EVM is like reducing the load of Ethereum. It is reducing the load of Ethereum. Say for there is a transaction to be done. So that transaction, entire thing, computation will be done by ZK EVM. And what ZK EVM will be doing once the transaction is complete, it moves to a new state. Once it happens, it will be sending the ZKP. It is not sending the entire transaction kind of thing. It is just sending the ZKP. Okay, zero knowledge proof, saying that the transaction is over and this is the proof of the transaction. So that way, no information is being shared, no computation details are being shared with the Ethereum node. So what is happening? With this, there is a cut down in the computation cost of Ethereum. Okay, so with this, ZKM is making it possible. Scalability is being made possible. Low computation costs are being possible. Better security, decentralized. These are all happening. The next keyword which can be connected is dApps. This is just decentralized applications. They are on many platforms, but here specifically mentioning Ethereum platform. Okay. Next is Nano. Nano is just like your Bitcoin only. So let us take a pause here, and I just try to highlight Nano somewhere from here. Yeah. Once I display this, I have also a request to my colleague and friend Sujan one. Post this. You're seeing this screen, right? Are you all seeing this screen? Okay, so I am finding, being a novice myself of the crypto world, I am finding this screen is more similar like the indexes, Bombay Stock Exchange, BSE or NSE or Singapore Exchange kind of thing. But I also see that this is dealing with cryptocurrencies. The representation is in US dollars, and the name of the currency being shown is here, Nano, is it not? So Nano is like Bitcoin, like Ethereum, like Monero, I can say. So Nano is a cryptocurrency kind of thing, right? And its rate in US dollars is being mentioned, is it not? Okay, so let us try to, I'll type INR. Yeah, I can see the cost of a Nano here. Okay, I'm going to Nano now. Are you able to see this Nano site? So, and what is Nano? So Nano again is deals with cryptocurrencies, digital currencies, and the highlight is without fees. And the highlight is without fees. So what I can do with Nano? Transactions, online payments, foreign exchange trading, banking infrastructure, remittances. Let us see if I can try Nano here. Okay. Where do I go? No. I'll go to view all the wallets. And I just go to this NOLT website. Yeah, what you are seeing here is actually my account which was created, and you can see here I have a nano with this balance. Okay, I'll just click on this. Should I click on this? Yeah, this much I received, right? I'll again go on clicking on this. These are the details I'm able to find, and this is accessible to anybody and everybody. I'll show you one screen. Yeah, what I'm trying to convey here is that where are we now? We are Nano. So Nano is kind of again a cryptocurrency. But I was telling you, I have a request to my colleague and friend Sujanvan sir, who is like a dedicated Nano follower, and he wanted to have give an appeal through me, but I am requesting him to do that appeal for more usage of Nano. Sujanvan sir, just for a minute, can you interrupt? Are you there? I was just. Is Sujan sir there? Okay. I'll just check out if he's there. Else, I'll just say that the appeal from the Nano community is that it is better than all the currencies for common people like you and me, because Bitcoin is taken over by rich people, being manipulated, being controlled, and many of the people are leading Bitcoin nowadays because there is a limitation of 20 millions, right? So Nano is the buzzword for common people like you and me. It is without fees. There is no fee involved. You can explore Nano to understand this cryptocurrency world. Okay. The next one is Monero. Monero also is a cryptocurrency, but mostly preferred by dark web people. IOTA also is a cryptocurrency. Okay. The next is hash, the keyword. So we know that we are converting a given value into another value. So I'll go back to my slide. I am at the first slide. We try to connect with all the keywords. And we'll move further. Hope this my slide is visible to you all. So I request one or two participants to speak about whatever you are seeing, what you feel about, what comes to your mind when you see this. Any one or two participants? I request two participants at least to speak about what comes to your mind when you see this. Anyone? Students, if any one of you are there.
Activity tracker.
Fantastic. Activity tracker, very good. Any other student? Can you? What comes to your mind when you see this? Just one of the students, because you use it, I don't have it. I belong to old era. Any one of you? What is this? Okay. Right. So we all know that this is a smart watch, right? And I'll be wearing this smart watch, as one of the students just said. This can be an activity tracker, like how many miles I walked, what is my blood pressure, what are my health related things, what can be my diet, everything is being tracked on this smartwatch. It means what, this smartwatch is kind of a computer, right? So, and so being, it has to do all the computations live. It means it has to be a very fast computer. It has to be a very fast computer. Let us say all the computations are being done on this machine itself, it becomes very heavy duty, costly and everything. And it is nearly impossible. That's why what happens? All the complex computations are moved to the cloud. All the complex computations are moved to the cloud, right? And at the cloud, all the computations happen of this smartwatch. But let us say we are incorporating ZKP here. What is the long form of ZKP? ZKP is a zero knowledge proof. ZKP is a zero knowledge proof. So what happens? Whatever the computations of this smartwatch are being sent to the cloud will not be sending all the computations. The cloud will be sending a proof saying that, boss, I have done the calculation. And this is the proof of that. And the smartwatch will be verifying, yeah, I verified it and he has done it. He has done the computation. This kind of thing. So that's what I have written here. Regarding that smartwatch, the complex computations of the smartwatch can be moved to a cloud. Cloud will be sending, say, the result, but are the results correct? Okay, so for that verification, ZKP can be used, zero knowledge proof can be used. So what the cloud will be sending? The cloud will be sending a ZKP, zero knowledge proof. Okay, and here the smartwatch is the verifier which will be verifying this and saying, yes, I got to prove that he has done the computation kind of thing. Okay. Now let us talk about privacy. Let us take my own case. I'm a faculty. I'm a very avid social media user. I use my WhatsApp. I use all my social media. I use YouTube. I'm I want to be everywhere. Except that I cannot compete with youngsters like you who are all again or everywhere, like including Insta and so on and so forth. So what we do on our social media, we share so many things, right? So which restaurant we went. For example, I took a lecture today. I may post a photo saying, fantastic lecture I did, took a lecture today kind of thing. Okay, the places I visit, I do everything. But is it like I want to share everything? No. I may not want you to check what I closed the whole day. I may not want my wife to know what trash food I ordered on Zomato. Okay. So it means what, though I want everything on my social media, I also am a private person. I can categorize what I don't want to be shared, what can be private and what can be public. Okay. And let us take one more example. Let us say you are using Book My Show to book a movie. Let us say a horror movie. A horror movie is a A-rated movie, let us say, and you are booking your ticket. Now, the Book My Show, let us say Book My Show says that, boss, this is a horror movie, this is an A-rated movie. You have to give your Aadhaar card, you have to give your PAN card, giving the proof of your age, Now, here your privacy is getting violated, right? Your privacy is getting violated. Why? Because you need not give all of that, your Aadhaar card and all the proof saying that your age is this. You need not tell your age also. Actually, what they're expecting, that you are an adult, that you are above 18. So how can that be done? Here, ZKP can play a role. Zero knowledge proof can play a role. You can say that, first, this is it. This is the proof of which says that I'm above 18. And the Book My Show window may have a verification system which says, yes, this is correctly proved kind of thing. Now, we are also avid watchers of Netflix and Amazon Prime and all those OTT platforms, right? So even in our house, we share our, nowadays Netflix is not being that much shared, but we share our passwords of this OTTs to our family members also. But we create our own profiles. Each profile gets a different recommendation system, right? This recommendation system also needs to be private. So I don't want that to be shared. Here also ZKP can play a role. Nowadays, gaming has gone to a totally different world, right? Though I am from the olden era, I can just observe from distance that youngsters are hooked to their avatars and they are kill this, go to this, conquer this kind of gaming things are happening. But there again, your avatars, your identities, there you need some shielding also there, right? So they need to be crypto enabled there also. So in the gaming world also ZKP can be used. So I'm just telling privacy or to prove that you are adult, to keep your recommendations private, to keep your avatars private in the gaming world. ZKP can be a contender for that. Okay. So I was speaking about this. Nothing is private in the Bitcoin world. This is a screenshot of what I have shown on the Nano, right? So you can see all the transactions. It means what? All the transactions can be visible, can be seen by anybody. How much amount is transacted, where it was transacted. So all my information is open. All my information is open. It means what? Blockchains, Bitcoins, Nanos, Moneros, these are all transparent. The concept has come from being transparent, from distributed ledgers. But now to add a shielding, we are going to make use of ZKP. We are going to make use of ZKP, zero knowledge proof. Okay. So if you look at the top heading, Bitcoin, there is no privacy because they are transparent. But if we add ZKP, which is zero knowledge proof, ZKP can introduce privacy to public blockchains. Say, for example, you have Zcash cryptocurrency, which is based on the ZK snark. ZK snark is zero knowledge sustained non-interactive argument of knowledge. Okay, so this is based on again ZKP. So there you can add up a privacy aspect. Okay, now the player is ZKP for blockchain evolution. So you will see another 10-15 years wherein ZKP is a rich enabler for blockchain systems. Okay. Now, what exactly are ZKPs? ZKP is zero knowledge proof. Here the word is proof. So ZKPs are proof systems. Okay. What these proof systems will be doing? They will be telling that the computation is correct. They will be telling that the computation is correct. What are ZKPs? ZKPs are cryptographic tools. ZKPs are cryptographic tools. They are linked to distributed ledgers. What are distributed ledgers? Our blockchains. Our blockchains. So it means what? ZKP, cryptography, blockchains, cryptocurrencies, these are all interrelated things for this world to evolve. Okay. Ethereum is what again? Ethereum is a blockchain. Ethereum is a transparent blockchain. Ethereum, the speed of Ethereum is very slow. The computation cost is very high. Say, for example, per second, 15 to 20 transactions may happen on Ethereum. Now, what can happen is all those computations which are happening on Ethereum, if they are outsourced to an external server, and the server sends back the result, and there is a mechanism which can say that this result is correct. That mechanism is the proof system called as ZKP, zero knowledge proof. Okay. So here what is happening is the number of transactions can be improved drastically, and scaling also is possible. Okay. So what basically ZKP does? ZKP is zero knowledge proof. What it proves? What ZKP proves? It proves that this transaction is valid. Okay. But it will not share anything about that transaction. It will not share anything about that transaction. That is ZKP. Okay. So let us take a pause for a minute, for a few seconds here, and because I feel if you are distracted a bit, you come back now and focus, because very interesting, simpler examples are going to be shared, which will again clarify, if it is not clarified till now, what exactly is ZKP through simpler, interesting examples, which are classic examples. Whoever teaches or learns ZKP for the first time, these are the classic examples. Give me 30 seconds. I'll have a water break and we'll take forward. Yeah. Just a confirmation for one or two. Are you all there? Because very classic. simpler, interesting examples of ZKP are being shared. Just from one or two, you are there, you say yes, you are there. I'm audible, everything is fine, you are there with me.
Yes, sir.
Fantastic, Shrutika, thank you. So, we are trying to understand the concept of ZKP, zero knowledge proof, through some simpler examples. If we are able to understand this example, we know the concept of ZKP. We know the concept of ZKP, right? Now, here we are finding a person. This person's name is Waldo. This person's name is Waldo. And this Waldo is in this crowd somewhere on this beach. Is in this crowd somewhere on this beach. Now there are two entities here. Okay. So let us say one entity is called as Victor or Peter. The other entity is called as Anna or something. Now let us say I take Indian names. Say for example, this is Waldo, and among my students, let us say Shrutika is there. Shrutika has to prove that Waldo is there somewhere in the crowd. Waldo is there somewhere in the crowd. To Laksha, let us say. To Laksha, another student of mine. But Shrutika will not tell Laksha where exactly is Waldo in the crowd. So Shrutika is not going to tell the location of Waldo, anything about Waldo. But Shrutika is going to convince Laksha that Waldo is there in the crowd. Waldo is there. This is a puzzle. This is a puzzle. Now, one solution can be that from this image, Shrutika will identify where Waldo is, and she may cut with the help of a scissor the picture of Waldo and give it to Laksha. So give it to Laksha. Is it not? So what Laksha may feel, yeah, Shrutika knows the location of Waldo. Shrutika knows the location of Waldo. But it may happen that Shrutika is very intelligent. Shrutika already has the pic of Waldo. She took that pic of Waldo and showed to Laksha. It is what Shrutika is telling a lie to Laksha. Shrutika is telling a lie to Laksha. So in that case, what Laksha may do is Laksha may use a watermark. Here, it is instead of Victor, you can assume it as Laksha's puzzle. So if an image is cut from this page, and by looking at the backside watermark, now Laksha knows that yes, this image is from the same image. This Waldo's pic is from the same image. This is one way of telling where exactly is if Waldo is there or not in this image by Shrutika to Laksha. The other way around is like this. What Shrutika may do on this image, Shrutika may put a very huge black paper, very big black paper, whose size may be multiple times of this image. And Shrutika may put a hole in that black image. And Shrutika will take that hole to the location where Waldo is. So in this hole, this is a hole. This is a black paper, huge block black paper, which is kept on that image, and Shrutika is just highlighting through the whole Waldo. Now Shrutika is telling you this is Waldo. So Laksha knows that Shrutika knows the location of Waldo. But does Laksha know that this is what is the location of Waldo? No. So this is called as zero knowledge proof. What is zero knowledge proof? Shrutika has not told about the location of Waldo to Laksha or anything about Waldo. Okay. So whenever zero knowledge proof is used in this kinds of example, three properties needs to be highlighted. One is completeness, that correct proof is accepted. Shrutika has given the correct proof and Laksha has accepted that. Soundness, invalid proof won't be accepted. Here invalid proof as in if Shrutika just takes a picture from somewhere else and says that this is Waldo. So that cannot be accepted. That is soundness. Zero knowledge. Zero knowledge is nothing is told. Nothing is told about Waldo, the location of Waldo, I think. So you are not revealing anything. You are not revealing anything, but still telling that I know everything. When such proof system mechanism happens, that is a zero knowledge proof. That is a zero knowledge proof. Let us take one more example. Are you all with me? So one of you identify the character. Right side character may be more easier. I'll highlight. Anybody can highlight this character? Who is he? He is an actor. Benedict. Okay. What is that? Again, Benedict Cumberbatch. But what is this role he playing? Sherlock Holmes. And who is his friend? Watson. Now let us look at the puzzle. Let us look at the puzzle. Sherlock has two balls. They are of different colors. One color is blue, the other color is red. Watson is color blind. Watson is color blind. So Watson is able to see the balls, but Watson is not able to see the color of these balls. Watson is not able to see the color of these balls. Okay. Now, what Sherlock has to prove to Watson? That these two balls are of different colors. These two balls are of different colors. How Sherlock can prove that to Watson? How Sherlock can prove that to Watson? I'll repeat. Take a pause. Look at this interesting example to understand the concept of zero knowledge proof. To understand the concept of zero knowledge proof. Look at the character. On the right side, you have Sherlock Holmes. On the left side, his friend Watson. Sherlock Holmes has two balls of different colors, blue ball and red ball. You can see the positions also. On the top, you have blue ball, on the below bottom, you have the red ball. And Watson is colorblind here. Watson is colorblind here. He doesn't know. He can see the balls, but he cannot see that they are of different colors. What Sherlock Holmes has to prove? He has to prove that these two balls are of different colors to Watson. These two balls are of different colors to Watson. How he will be doing it? Let us try to do that. Okay. What Watson has done here? Watson has taken those two balls from Sherlock, and he took those two balls to his back, and he may shuffle, he may not shuffle. He may shuffle, he may not shuffle. Okay. So if you see the first position, blue ball is in the top, red ball is at the bottom. Now Watson has shuffled the balls. Watson doesn't know they are of different colors, but he will ask to Sherlock, are they switched? So Sherlock will answer yes, they are switched. Watson will again take the ball back. He will again shuffle them. He will go on asking Sherlock Holmes, are they switched? So if they are switched, Sherlock Holmes will say they are switched. If they are not switched, Sherlock Holmes will say they are not switched. It means there is iteration, repetition happening. As more number of iterations happen, more number of confidence level, more number of truth being spoken and proof being verified. That happens here. But did Sherlock Holmes tell ever to Watson the color of the balls? This ball is of this color? No, never. But what is happening here is there is a lot of repetition, lot of iteration happening, and a lot of interaction happening between Watson and Sherlock. Okay. So this is the characteristics of this example related to zero knowledge proof. It is repeated many times. Never the color is revealed. So here zero knowledge concept is used. It used probability theory because switch, not switch, like that multiple times. Again, the three properties are explored: completeness, soundness, zero knowledge. Okay. But here you see that this is a repetitive interaction happening. You also know that zero knowledge is never Sherlock Holmes told the color of the ball to Watson. Completeness, so every time the ball is switched, shuffled, Sherlock Holmes gave the correct answer because he is not colorblind. Soundness, okay, Sherlock Holmes could not deceive Watson, That's what is the second example. Let us continue this example with the hash function. Okay, now this is a hash function, right? So I try to see what this hash function will be doing. This hash function will be using this SHA-256. It will be applying on this say key called as W, and the resultant is say X. Okay, so here we are using X and W. We are written function in C. Let us say now my X is a secret value. Okay, the hash of the secret value, and my W is the actual secret value. Now, what this will be giving you, it will be giving you a Boolean value of answer yes or no, whether it is equal to X or not. So This is the continuation of the previous two examples. Means in the mathematical and the computing world, how this WKP can be implemented. How this WKP. Now, this implementation can be done with the help of ZK Snark. What is ZK Snark? We already know. Zero knowledge, succinct, non-interactive argument of knowledge. Okay. What is zero knowledge? We can prove that a fact is there without revealing the fact. What is succinct? I already told, it is small. What is non-interactive? In the previous example of Sherlock Holmes and Watson, there was huge interaction happening, but it should not be there. It should not be there. So in this proof system, it is non-interactive. What is an argument here? Actually, proof is the argument. Okay. What is the knowledge? Knowledge is the information that the prover knows. Now, here, when I want to implement this ZKP through ZK Snark, the algorithm has three things: setup, verify, and prove. Okay, so here PK and VK, which I am highlighting here, is they are the keys. One is the proving key, the other one is the verification key. Let us take our previous example of Sherlock Holmes and Watson. So who is prover? Sherlock Holmes is the prover. Who is verifier? Watson is the verifier. And this is a secret value lambda. This is a secret value lambda. Okay, and this is a C program for that function. Okay, so the prover will be generating a proof. Okay, the verifier will be verifying that proof, and the answer will be coming with the help of Boolean value, yes or no. Yes, it is proved. Yes, it. So this kind of thing happens in the ZKP world. How I see in the future ZKP can be used, ideally speaking, in these. Presently they are being used in Zcash, Bitcoin, privacy. Whenever I want to achieve privacy in transparent world, I'll be using ZKPs. But I'll also maybe using, say for example, in future revolution happens and I want a redistribution of wealth. So I may be using these kind of algorithms. Auctions, a lot of auctions. You see electronic votings, nuclear disarmaments, cryptocurrencies, Wi-Fi protected areas, finance, real estate. So everywhere and anywhere, ZKP is going to play a big role. So with this, I stop my discussion. And thank you for patiently listening. I request any questions are there, please do ask me.
Any questions from the participants, please?
If you have some mic problem, you can put in the chat window also. Okay, I think, okay, few may be asking in the chat window. Yeah, somebody asked, zero knowledge proof secure? How do I answer it? They are secure, they are not secure. It is more on the lines of they are dependent on a property of mathematics, that few mathematical problems like factorizations are difficult to compute, difficult to solve. So mathematical hardness, computation hardness, assumption is their dependency. Actually, sorry, I did not go through the chat previously, but there are a lot of responses here. Thank you for that. Sumani had asked, can you give more examples? Sure. I'd like to share, how do I put it? Electronic voting. I just mentioned few examples, right? You can say electronic voting. What is electronic voting? I will be giving my vote. My vote should be not known to you, but how many votes are given, that computation, who is the winner, that computation is to be done. In such cases, you can make use of it. I think my friend Sujan sir also asked me one or two questions through the chat, our WhatsApp chat actually. He is asking what are the challenges of ZKP. That is
designing the protocols, security, basically explaining to novices like me what exactly is ZKP. That can also be a challenge. Where the ZKP can be used, I just mentioned ZKP can be used anywhere and everywhere. Finances, real estate auctions, even the example which we like in the classic example is your combination lock for a suitcase. You need not tell the combination, but you will be telling that you know the combination kind of. Thank you, Sumani. Same question. Can zero knowledge proofs be implemented in non-digital scenarios? Yes, I just mentioned one example that combination locks can be one example. Real estate auctions can be another example. Hope I could answer this. Any more? Just a confirmation. Just a confirmation. Among the participants, those who are listening, how many could at least get some understanding of what is ZKP? Yes, no. Answer yes, no. You can give. I'll be sharing my PPT as well as my video in future. Yeah, thank you, Sanjana, Sumani. Yeah. Oh, great. Yeah. Thank you. Thank you. Got it. Yeah. Okay. So I enjoyed the session, and we'll continue our learning curve of ZKP and this distributed ledger world. Thank you for patiently listening. Thank you for having me. IETE, Om Namah Shivaya sir, Krishna Prasad sir. Give me more opportunity.
Sir, I'm Dr. Srinivas Reddy, Fellow of IETE.
Sir.
Good afternoon, sir. Now, respected IETE members, it is my privilege and pleasure to propose vote of thanks for enlightening lecture on zero knowledge proof. It's a cryptographic solution which was organized by IETE Hyderabad chapter. I would like to thank you for all joining us today and your active participation and interest. I am honored to have this kind of lecture by Dr. Eminent personality, that is Dr. Rajesh Kulkarni, who is a renowned expert in cryptographic and working in MVSR Engineering College as a professor. Dr. Kulkarni sir has given a fascinating overview of concept of application of zero knowledge proofs, which are powerful tool for ensuring privacy and security in various domains. He has also explained challenges and opportunities for implementing zero knowledge proofs in real world scenarios. I would also like to express my gratitude to IETE Hyderabad chapter for organizing this lecture as a part of their series on emerging topics in engineering and technology. I would like to thank Professor Nuli Namashivaya sir, Chairman of IETE chapter, for his vision and leadership in bringing such eminent speakers to the IETE. And I would also like to thank Ashwini Kumar sir, Secretary of IETE Hyderabad chapter, for his meticulous planning and coordination of this event. I would also like to acknowledge the support of our senior members of IETE and honorable office bearers for organizing this particular event. And dear respected members, once again, I thank all of you for your presence and attention. I hope this session gives a lot of information for you. And I request you to stay in touch with IETE Hyderabad chapter for more informative and inspiring events in future. Thank you, sir, Dr. Kulkarni sir, for your wonderful and excellent informative session. We are very grateful to you for your valuable time with us in revealing a fantastic and information on this particular security solution. Thank you, sir. Thank you, one and all. Hello.
Yes, sir. Thank you. I'm leaving now. Thank you, all students.
Hello.
Thank you. I'm leaving now. Thank you, all students.
Thank you, sir. Thanks a lot, sir. Thank you for your great presence.